All right, hello everybody. This is another FRAPPY day. We're going to go ahead and tackle the FRAPPY for the year 2006. We're going to do question number 1. We're going to walk through that together, and I'm also going to talk you through the rubric. It can take a little while to get used to looking at these rubrics, so we're going to go through that together, and then you are going to have a FRAPPY to try on your own tonight from the year 2007, the B version, problem number 1. Okay, and remember we said when you do these, you are allocating about 15 minutes. You're doing the absolute best that you can, and then you're going to use the rubric to score however your answer is, no matter how bad it is, and just in pen, you'll just make corrections off to the side of, this is what I should have put, or I just didn't put enough of details for my explanation, and you'll just kind of write what it should have been. Okay, so here's a couple things that you need to just keep in mind when you're answering any of these questions. A lot of times, especially when you're doing these written justifications, this is what the grader is doing here. An E, if they give you an E, that means you have really strong communication and a really great argument. If they give you a P for partially correct, that means you did a good job, but your communication could be stronger, or you could have better articulated your argument. So here's what you need to try to remember. The grader only knows what you say. Okay? They are not allowed to assume what you know or think, well, I think I know what they're trying to say. They can't. So you have to give evidence to support your answer. Okay? You have to give evidence to support your justification. Okay, so with that said, let's move into the 2006 problem number 1 FRAPPY here. Okay, you can see at the top it mentions about giving yourself roughly 15 minutes. We have 2 parents. They each have built a toy catapult for use in a game at an elementary school fair. To play the game, students will attempt to launch ping pong balls from the catapults so that the balls land within a 5-centimeter band. A target line will be drawn through the middle of that band shown in the figure below. All points on the target line are equidistant to the launching location. Okay, so first of all, I just want to make sure that we have an understanding of what is pictured here. At this launching location would be where the catapult would be placed. They could kind of aim it at various angles here. They launch. As long as it lands anywhere in the shaded band, which has a width of 5 centimeters, they would win a prize, it says here. If a ball lands within the shaded band, the student will win a prize. Okay, but they're targeting, their goal is to try to hit the very center of this band here. Okay. The parents have constructed 2 catapults according to slightly different plans. They want to test these catapults before building additional ones. Under identical conditions, the parents launch 40 ping pong balls from each catapult, and they measure the distance that the ball travels before landing. Distances to the nearest centimeter are graphed in the dot plots below. Okay, so once again, they have 2 catapults. They used each of those catapults to launch 40 ping pong balls under the exact same conditions. You can see these dot plots here. What we have down here is the distance that ball traveled in centimeters. Okay, so these are both distributions as we've been discussing here. Okay, we've talked about how to compare 2 distributions. Let's look at what part A is asking us to do. Okay, part A, it wants us to comment on any similarities and any differences in the 2 distributions of distances traveled by balls launched from catapult A and catapult B. Okay. Anytime you are asked to compare 2 distributions, you need to think of the acronym CUS. Whoops. Okay, you want to think of that acronym CUS, okay, where we're going to compare the center, any unusual values, the spread, and the shape here. Okay, and you can do that in any order here. Okay, what I tend to like to do is I actually like to discuss the spread first. No, I'm sorry, the shape first, because if the shape is skewed, then it is better that you are choosing the median as the center rather than the mean. Okay, so let's take a look at the shapes of each of these. Okay, remember we're just going to picture roughly, drawing a curve over top of these here. Okay, we're definitely kind of getting the sense that as we compare these two, they both kind of look like they're approximately symmetrical, and they look unimodal, that there's one kind of mound for each of those. Okay, so I'm going to go ahead and say here that this is our S for shape, that both the graphs are roughly symmetric and somewhat unimodal. Okay, so they're kind of similar in that. Okay, the next thing we're going to address is we're going to address the center. Okay, and I'm going to show you where I got these numbers from. I'm going to go ahead, I know I just said when it's symmetric, it is better to choose the mean. But, on something like this, I think it mentioned that there were 40 ping pong balls that were launched. It's a little easier. Keep in mind, you only have 15 minutes to do these problems on the AP test. It's a little bit easier to just count in 20 dots from the left and count in 20 dots from the left on each of these to just kind of pinpoint where the median would be. Okay, so if you would do that, count 20 dots in on the left and then 20 in on the left for catapult B, I think that you would discover that the typical distance, okay, so we're talking about the center, the typical distance for catapult A, the median is roughly 136 centimeters. And that is it's just slightly lower. See how I'm using comparative language here? It's slightly lower than the typical distance for catapult B, which is 138 centimeters. Okay, so we said 136 and 138. I'm just going to mark those right here with a little arrow. That's roughly the center. And that's roughly the center, just so I have that to look at back at this. Okay, so we've done the shape, we have done the center. Let's go ahead and look at the spread. Okay, there are different ways you can say this, but certainly when you look at the two graphs, you're going to notice that there is definitely more spread or more variability in the distances traveled if you were to use catapult A rather than catapult B. Okay, now I'm going to show you where I got these numbers from here. Okay, you can see here that, for catapult A, there were a few that were really short, and then there were some over here that were much longer. See how catapult B is a little bit more reliable, I guess we'll say, because it doesn't have quite as much spread. So I went ahead and just estimated roughly what I thought this number was to 155 for catapult A, and then what I thought this measurement was to this one for catapult B, and that's where I got these. Okay, and when I listed them, I just listed my first group of numbers is representing the distances traveled, from smallest to largest for A and then for B. Okay, and again, I'm using that comparative language because I'm using the word there's more variability or there's more spread. Okay, finally, unusual values. Okay, these are our outliers. Now, we don't have to use that outlier rule with this particular problem. Okay, I'm not going to say that things are definitively outliers, and I know that as a fact unless I use the rule, but I'm just going to mention that maybe it looks like some things could be outliers. Okay, it really doesn't feel like catapult B has any outliers, but in A, it's possible that this one here could be an outlier. And maybe some of these are outliers. And so I'm just going to mention here that catapult A has some values that may be potential outliers. And I just commented, and this again is to the point where you're just trying to use really good communication. There's more high than low. And what I mean by that is, there were a few more dots up here higher away from the general grouping than there was lower. Okay, so that's what we're referring to there. Okay, and so we're going to move on to part B. Part B says if the parents want to maximize the probability of having the ping pong balls land within the band, which one of the two catapults, A or B, would be better to use than the other? And look right here, this is infamous in statistics. You have to justify your choice. Say why you're choosing which one. Okay, so if they want more balls to land in the band, which one would be a better choice? So let's look at this and think here. Okay, remember, catapult A, well, it did have a lot right here. You know, there were some times where things were lower, few times where things were really high. You know, catapult B feels like it's centered a little bit more here, okay? Where it's just kind of all falling about in the same area. Okay, so you could say something like this. Catapult B would increase the probability of the ping pong balls landing within the band. Okay, so there's my choice. Now here's my justification. This is because the distances for catapult B varied much less than catapult A. Most of the balls for catapult B landed in a 5 centimeter range from the center, which increases the likelihood of hitting that narrow band. Now, I want to make sure you understand what I mean here when I said that, within a 5 centimeter range from the center. Let's go back to the graph. Okay, you can see on catapult B where I have the arrow right here. Maybe it looks like it's about 138. Okay, 138 is the median. If I go, 2.5 to the left and 2.5 centimeters to the right on each side, I'm roughly, I'm getting most of those balls. Okay, there's some that are out, but I'm capturing most of them are landing in that band. Okay, so that's the reasoning there. Okay, then part C. Part C says if you were to use the catapult that you chose in part B, which we're choosing catapult B, how many centimeters from the target line should we place the catapult? And explain why we're choosing this distance. Okay, so let's look back at our picture here. Okay, they're saying if you can decide what this distance is from the target line back to where you're going to place it, what would be that distance that you would mark here? Okay, and so if we're saying that most of these dots that would go 2.5 on each side of the 138, that we're going to include almost all of them here, I think 138 might be just a fine choice here. Okay, so we could say something like catapult B should be placed 138 centimeters from the target line, since this is the typical distance or median that the balls travel. Okay, this means that any balls landing within 2.5 centimeters of 138 centimeter target line would fall in an acceptable range of, and then this is me subtracting 2.5 centimeters and adding 2.5 centimeters to the 138. Okay, now I'm taking this a step further, which a lot of times the rubrics demand this. It says using the sample data, I'm talking about the dots in the dot plot, and we'll go back and look at this. 30 of the 40 balls landed in that window right there. Okay, and that window is 2.5 smaller than 138 and 2.5 centimeters larger than 138. And 30 out of 40 is 75% of the balls then would be landing in that range. Okay, and I simply counted that. Okay, so what was the range here? 135.5 to 140.5. Okay, let me clear this off here. Okay, so we're saying 135.5 to 140.5. Okay, so that means I would include everything to the right of this green line for 135.5. Okay, and then I need everything to the left of 140.5. That would be everything to the left of that. Okay, if you were to add up the number of balls that fall in between there, that's 30 out of the 40, or you could count the balls that are outside here that didn't hit the target, and that would be 10 of them, and so it's hitting 75% of the time. Okay, so most of the FRAPPYs, the first one we did wasn't like this, but most of the FRAPPYs have E, P's, and I's for us here. So when we go through the rubric, we can just circle if we got it essentially correct, partially correct, or incorrect. Okay. Now I think I gave you the rubric for this, but again, I'm just going to show you really quickly here. If you were to go to my website, okay, if you were to go to my website and click at the top where it says free response question rubrics, okay, free response questions rubrics here. Can get that to work here. There we go. Okay, and we're going to tap that link. Okay, this one we just completed was the 2006 question number 1. Okay, I want you to be comfortable with looking these up online yourself. Okay, I'll give you the rubrics at the beginning, hard copies, but you need to know where to go online. Okay, 2006. Now make sure you're careful and you don't pick Form B. You want to pick this one right here. Okay, that's this 2006. Okay, and then you're going to pick scoring guidelines. Okay, now this is question number 1, and if you scroll down, it's going to start to give you that model solution, which again I have for you here already. Okay, so I do encourage you to read the solution aspect. Okay, just keep in mind that sometimes there's more than one way to do these problems, and they're just giving you one way to do it. Okay, when they give you the solution. But you can look at that to compare to your answer, but then your focus needs to be right here where it starts talking about the scoring. Okay, so for part A, okay, and once again, I'm just going to flip back real quick here. Part A was when we were cussing, okay, and we were describing the center and usual values, the shape, and the spread. Okay, look at what it takes to get essentially correct. Part A is essentially correct if the student correctly identifies similarities and differences in center, spread, and shape. Okay, now, partially correct is if you identified similarities and differences in 2 of those 3, center, shape, and spread. So if you only did 2 of them and you didn't compare their spreads or compare their centers, then you're getting a P. And incorrect is no more than 1. So even if you just did 1 similarity, it's still an I. Always look at the bottom, and if there's any extra notes, read them, okay? Like here it says, any correct comments regarding outliers, that was our U, unusual values in the CUS acronym, should be viewed as positive. However, comments about the outliers don't count as one of these 3 comments. So here's what you commenting about the outliers could do for you. If you scored like a 2.5 or a 3.5, that could be extra communication that could bump you up to that next level for an overall grade on the free response question. Okay, let's look at, here's some extra notes here, which you can read those. We're going to look at part B, essentially correct if catapult B is chosen using rationale based on the variability in the distances. Okay, you're only getting partial correct if you pick catapult B, but your explanation that you gave doesn't talk about how catapult B had less spread and less variability, and that's why we wanted to stay away from catapult A, because it had all those outliers and it was more erratic. Okay, all right, then part C, it says you're going to get an E, and there's an or here, so you could do one of 2 things. You get this essentially correct if you say that the catapult should be placed at the median or the mean, okay, which I think we said 138, which was our median. And, okay, there's an and here, you also have to explain, have an explanation that addresses why the median or mean was selected. Okay, I think we did the second part here where the catapult is placed at 138 maybe, but then we explained that that chosen distance resulted in a really high proportion of balls from the sample, like 30 out of the 40 would have landed in our target band. Our target band was slightly different than what they have here. You would get full credit though for what we had put. Okay. All right, so for us, we would have gotten E's on all the parts, but if you scroll all the way down here to the bottom, you can see this tells you all 3 parts essentially correct. You're getting a 4. If 2 parts were essentially correct and 1 was partially correct, that's going to knock you down to a 3. And they give you all these different combinations that you can just see where you fall to give yourself your score. Okay, once again, these scores are not going to be necessarily the grade that you're getting in progress book, but this would be your AP score on that particular test. I'm interested in, did you use the rubric to score yourself correctly, not how did you score here. Okay, looking at these rubrics, guys, is gold. It really, really is. Okay, hopefully that helps. You are asked to now do the 2007 B